Your EV's dashboard says everything is fine. Zero warning lights, software updated, battery at 100%. But professional EV mechanics check 9 specific things every 3 months that your car's computer never monitors. Things that silently degrade until they cause $8,000 cooling system failures, seized brakes, and mysterious electrical problems. I've spent 2 months shadowing certified EV technicians. Today, I'm showing you exactly what they check every 3 months that keeps EVs running smoothly for 200,000 plus miles instead of becoming problem vehicles at 80,000. They check the things software can't detect. Most EV owners trust their dashboard completely. Software monitors battery health, tire pressure, coolant temperature, and dozens of other systems. Warning lights appear when something goes wrong. Mechanics know this creates a dangerous blind spot. Your car's sensors can detect physical wear that happens slowly over time. They can't see a bushing that started cracking. They won't notice loose underbody panels until they're dragging on the highway. Software doesn't catch suspension components wearing unevenly. Every 3 months, experienced mechanics perform visual inspections that no computer can replicate. They crawl under the vehicle, looking at suspension components, ball joints, control arms, tie rod ends. These parts carry the full weight of your EV, which averages 7 to 1,000 pounds heavier than comparable gas vehicles. That extra weight accelerates wear. They inspect bushings and joints for cracking, separation, or excessive play. A failing bushing costs $150 to replace. Wait until it completely separates, and you're looking at suspension damage, alignment problems, and a $1,200 repair bill. They check for underbody damage from road debris, speed bumps, or winter driving. EVs have large battery packs mounted low. One hard impact on the wrong object can crack a battery enclosure seal, allowing moisture intrusion that leads to corrosion. They verify all protective shields and panels that are secure. Loose heat shields rattle. Detached aerodynamic panels reduce efficiency. A $3 bolt that vibrates loose can turn into a $400 part replacement when that panel flies off at highway speed. The physical inspection takes 15 minutes. It catches problems while they're still cheap to fix. They inspect the cooling system, not the battery. Everyone worries about EV battery health. Range anxiety dominates conversations. Charging speeds get obsessed over. Almost nobody thinks about the cooling system until it fails. Here's the reality. Your EV battery depends entirely on thermal management. Batteries generate heat during charging and discharging. Keep them in the optimal temperature range, and they last 15 plus years. Let them overheat repeatedly, and capacity degrades rapidly. The cooling system makes this happen. It's not a single component. It's multiple circuits managing battery temperature, power electronics, and motor heat. Every 3 months, mechanics check coolant levels in both the battery cooling circuit and the power electronic circuit. Low coolant doesn't trigger immediate warnings. The system compensates until it can't anymore. Then you get thermal throttling, reduced charging speeds, and eventually component failure. They inspect every visible hose for condition. Coolant hoses in EVs operate under different pressure and temperature ranges than gas radiator hoses. Age causes them to become brittle. A pinhole leak drips coolant onto the battery enclosure. That moisture causes corrosion that spreads. They look for residue, stains, or dried coolant around connections. Early detection of a weeping hose joint costs $85 to fix. Discovering it after the cooling system failed during a fast charging session costs $3,500 in emergency repairs, plus towing. Cooling issues don't show up immediately. The car might display slightly lower DC fast charging. You might notice reduced range in hot weather. By the time warning lights appear, significant damage has often occurred. Quarterly cooling system checks prevent catastrophic failures that total vehicles. They check brakes even though EVs barely use them. Regenerative braking means your friction brakes do less work. That sounds like pure advantage. It creates an unexpected problem. Traditional brakes wear out from use. EV brakes corrode from lack of use. Think about it. Your friction brakes might only engage 30% as often as they would in a gas car. That means less heat cycling through the rotors, less friction cleaning the rotor surface, more time sitting static while moisture accumulates. Every few months, mechanics visually inspect brake pads and rotors specifically for corrosion, not wear. They look for surface rust on rotors. Light rust burns off during normal use. Heavy rust buildup indicates the brakes aren't being used enough. That rust causes uneven braking, pulsation, and eventually rotor replacement. They check for rust developing inside the pad-to-caliper contact points. Rust here causes sticky calipers. The caliper doesn't release properly after braking. You get dragging brakes, accelerated pad wear, and reduced range from the constant friction. They verify calipers slide freely on their pins. Lack of movement causes uneven pad wear. One side of the pad contacts the rotor more than the other. You end up replacing pads that are half worn because one section is completely gone. This happens more in EVs than gas vehicles. The solution is counterintuitive. Occasionally, use your friction brakes hard. Find an empty road once a month and do several firm stops from 40 miles per hour without letting regenerative braking do all the work. That heat cleans the rotors and keeps calipers moving. Mechanics know that EV brake problems don't show up as squeaking or grinding. They show up as seized calipers requiring $600 repairs that proper inspection would have prevented. They look at tire wear patterns, not just tire pressure. Your tire pressure monitoring system alerts you when the PSI drops, completely useless for detecting the tire wear patterns that EVs create. EVs are heavy. The instant torque delivery is aggressive. These factors create specific wear patterns that tell mechanics what's wrong before other symptoms appear. Mechanics examine wear patterns across the entire thread surface. Inner edge wear indicates negative camber from worn components. Outer edge wear suggests aggressive cornering or underinflation. Feathering indicates toe alignment issues. Cupping points to worn shocks or struts. These patterns reveal problems that haven't triggered any warnings yet. Alignment off by half a degree? Software doesn't know, but your tires do. Mechanics see these problems immediately. Catching alignment problems early saves $800 in premature tire replacement while also improving efficiency. Hit that subscribe button and click like if you're discovering maintenance habits that actually protect your EV investment. They test the 12-volt battery before it causes weird problems. Everyone obsesses over the big battery. The 75 kilowatt per hour pack under the floor gets all the attention. The little 12-volt battery in the corner? That tiny thing causes 40% of all mysterious EV electrical issues. Your EV has two battery systems. The massive high-voltage pack powers the motor. The small 12-volt battery powers everything else: computers, locks, lights, displays, and critically, the high-voltage battery disconnect relay. When that 12-volt battery gets weak, weird things happen. Random warning messages appear, then disappear. The touchscreen glitches, charging sessions fail to start, door locks act erratically. In extreme cases, the entire vehicle shuts down because the high-voltage system can't activate without the 12-volt battery energizing the safety relay. The problem? The car doesn't warn you effectively until the battery is already failing. Every 3 months, mechanics test the 12-volt battery with proper equipment. They check voltage under load. A 12-volt battery should maintain 12.4 to 12.7 volts at rest. Under load, it shouldn't drop below 10.5 volts. Weak batteries show normal resting voltage, but collapse under load. They perform capacity tests that stimulate actual electrical system demand. This reveals batteries that are losing capacity before complete failure occurs. They inspect terminal connections for corrosion or looseness. Corroded terminals cause voltage drop that mimics a weak battery. Quick cleaning prevents misdiagnosis. Here's what most EV owners don't realize. Your high-voltage battery keeps the 12-volt battery charged, but it doesn't preserve 12-volt battery health. Those small batteries still age, still develop internal resistance, and typically last 3 to 5 years. Replacing a 12-volt battery costs $150 to $250. Diagnosing mysterious electrical problems caused by a weak 12-volt battery costs $500 in diagnostic time. Getting towed when your car won't start because the 12-volt battery died completely costs another $200. Smart mechanics replace 12-volt batteries proactively at the first sign of weakness. They don't wait for failure. They clean and inspect charge ports. You plug in your EV without thinking about it. Cable connects, charging starts, done. Until one day it doesn't, and you have no idea why. Charging problems often seem electrical. Software glitches, charging malfunctions, network issues. Mechanics know that 30% of failed charging sessions have purely mechanical issues. The charge port itself requires regular inspection and cleaning. Every few months, Mechanics examine the charge port receptacle. They're looking for dirt, dust, moisture, and corrosion. Charging happens through electrical contacts. Contamination on those contacts disrupts current flow. They check for debris accumulation. Parking under trees, seeds, leaves, and organic material work into the charge port. Rain events push dust and dirt inside. That debris interferes with proper cable seating. They inspect for moisture intrusion. Water sits in the port, causing corrosion on pins and contacts. They verify locking pins function smoothly. Stuck pins mean the cable won't lock properly, potentially causing intermittent connection during charging. Cleaning a charging port takes 5 minutes. Replacing the charge port assemblies because corrosion destroyed the contacts costs $800 to $1,200. They review software status, not just for updates. Your EV prompts you when software updates are available. That's not what mechanics mean when they review software status. They're analyzing system data that reveals problems before they cause failures. Every 3 months, mechanics dive into diagnostic logs. They check error codes, including soft faults that don't trigger warning lights. They monitor charging speed consistency. If DC fast charging speeds have decreased 15% over 6 months, something's degrading. They review regenerative braking behavior. Declining regen efficiency indicates motor issues, power electronic problems, or battery degradation. This deep software analysis catches problems that would otherwise go unnoticed until complete failure. Mechanics review this data every 3 months because trends reveal everything. They retorque critical fasteners. EVs are exceptionally quiet. That silence means you hear problems later than you would in a gas vehicle, except when fasteners loosen gradually over time. No sound, no warning, just slowly increasing play until something breaks. Every few months, mechanics retorque critical fasteners throughout the vehicle. They check suspension bolt torque. Road vibration, temperature cycles, and stress cause fasteners to gradually loosen. They inspect underbody fasteners, securing battery trays and proactive covers. Loose bolts allow components to shift, creating wear patterns that eventually cause failures. A loose suspension bolt doesn't announce itself until significant play develops. Retorquing critical fasteners takes 20 minutes. It prevents failures that cause accidents or leave you stranded. They take the car on a purposeful test drive. Before returning your EV, mechanics conduct a systematic evaluation that catches problems only apparent while driving. They test regenerative braking smoothness at various speeds. They evaluate steering feel. They test the transition from regenerative to friction braking. They listen for noises over bumps. They verify drive unit performance during hard acceleration. Many problems only appear while driving. A test drive under various conditions reveals issues that would otherwise send you back to the shop a week later. EV maintenance isn't about oil, it's about attention. Electric vehicles don't need oil changes or tune-ups. Scheduled maintenance costs average 6 cents per mile compared to significantly higher costs for gas vehicles. That doesn't mean they maintain themselves. EV maintenance focuses on physical wear that software can't detect, cooling systems that operate silently until they fail, the electrical components that degrade without obvious symptoms. The mechanics who keep EVs running past 200,000 miles without expensive repairs follow the same quarterly routine. They check the 9 things your dashboard ignores. They catch small problems before they become catastrophic failures. Your electric vehicle represents a simpler powertrain with fewer moving parts. That means less maintenance overall. It also means the maintenance you do perform matters more because each system is critical. Share in the comments whether you knew about these quarterly checks, and subscribe for more EV ownership information that goes beyond charging speeds and range tests. Your EV's reliability depends on attention, not just software updates.